Okay.
So here, the distance r1 will be initial the velocity times the time plus, is that right?
Mm-hmm.
And the time, you know, is you understand here? Is the delta velocity divided by the acceleration will be the time,
Okay.
right? From this, you can calculate, put t into here, plus to know here is negative g. So here will be and so on. Which will be right.
Now it's starting to get a little too complicated now. With the calculation of the time is what started getting me. Like that's the same way we did on question 21 and 22.
The time
like
is
just to get the time
the time you know here, right? How we got this?
right, and that's the thing. Like,
So what's the time from your formula here, right? Acceleration, the velocity change divided by the time change.
mm-hmm.
You know that. So time is, if you move it just here, is a change of velocity divided by the acceleration. You don't have any problem here.
Mm-mm.
So here is will be 0 initial and negative g here, 9.8.
But v initial is 0 also, right?
No, the initial, when the ball starts to jump, the initial, it must have an
Oh,
initial.
okay.
Initial velocity is 0. When you reach the maximum height, it becomes 0. So that's the velocity change. That's the acceleration.
So now how do we get the numbers?
Which number?
The v initial. Because looking at it in that form there, I think that's what's confusing me. If I saw like numbers, then I would be. I see how you get the time. That makes
Yeah.
perfect sense.
Yeah.
How do we get v initial?
From this. This makes sense, no?
No, it makes sense. I mean, how do we get the numbers?
That's 3 seconds. Tells you after 3 seconds is reached the maximum. Right?
Mm-hmm.
So from this, the velocity, initial velocity will be 3v, which is 3 times 9.8. That's the initial velocity. question here?
Yeah, I see how you did it. You do it different how he teach it, but I understand what you're doing.
But I don't know how he teach it. You have those formula. That's what formula he gave to.
No, it's you're right, but to get the time and all of that, I never saw him do it this way. I mean, you're right. That's how you get the velocity and initial velocity.
Yeah.
I just never saw it in that form, so that's why it looks kind of strange. But you could keep going. But it would be 3 times negative 9.8
3 times.
because in free fall, so G would be negative 10, right?
Yeah, that. No. It's negative and negative, so it cancels off. So it's negative. So actually, it's the time, the velocity. If you consider that's positive, it will be positive. The initial velocity. It's along the y axis.
Okay.
So, but I told you there's another formula is, and you have it here, is velocity, the average velocity times t is r1, is this distance. You don't need to use this complicated formula.
I'm just going to stick to what I know.
Yeah?
Yeah.
I think I teach other students, they learn what is the average. In a constant acceleration situation, the average will be, in this case, it will be initial velocity divided by 2. You guys didn't learn this in class.
He probably did, but he don't teach it that way. He probably just,
Okay.
he explains it's more than one way that you can do it. So he teaches us the way that I guess will be standard for him to teach everyone.
Okay. I mean, this way is when you calculate it, it will be easier. I try to do it this way because you have the formula that you are familiar with. But there are definitely more than.
So the initial velocity would be 30 meters per second.
Around 30, yeah.
Okay. So then what's next?
And the next thing is you need to, and then you start to fall, right? The second process. The initial velocity here is 0 when they reach the maximum. It's 0. And the time, the acceleration is 9.8 because it's accelerating. And the time is 2.5. So you use the same thing is 2 is t plus t squared. So here is 0, 9.8, 2.5 squared. So, I mean from here and here, you got a number. It's just a calculation, right? And then in the end, you want to get here. That's R2, R1. Here is R1 minus R2.
Because it's going back down.
Yes.
So you subtract them.
Yes, you subtract. So, I mean, if you calculate, it's going to be 13.4 meters.
So the overall purpose of this question is you're finding the distance of one, right?
One process and the other
And then
process.
you finding the distance of the other process.
Yes.
and then you subtract them.
Yes.
Subtract the two.
Yes. This
Because they're going in
question-
opposite directions, you would subtract.
Subtract. The other question is the rocket one.
It was
It's
the rocket
the
one.
first and the second, but you do addition of
Right.
the two process. So it's just you need to, maybe they give you a complicated process. What you need to do is to be able to separate them into several individual process, and then either you do addition or subtraction according to different situations.
Okay.
Okay.